Welcome to TJ channel. Today, we are going to make things easier in life as we journey to another discussion. Graph coloring. Have you heard that word before? If not, then come with me and I will be discussing it with you on this video. I am Trisha Jeriss Basaca and I will be your host for today's episode of TJ channel. Let's get started. We all know that the year 2020 cancelled all our scheduled plans since the outbreak of the novel coronavirus last 2019. It has been negatively affecting all the people. Now is the time to make use of our time and learn something new and resourceful. In today's episode, you will be learning about easier scheduling and assigning, which will be very handy in proper scheduling patterns that creates effectiveness in dissemination of tasks. Using accessible and convenient scheduling would cut costs and taking advantage of time is very crucial in making schedules that will be optimized of all possible resources, especially in this time of the pandemic. Lastly, it will help in solving real-life problems. Applying the concept of graph coloring is one of the most vital concepts in graph theory, and it is exploited in many real-time applications like map coloring, scheduling, network security, and global system for mobile phone networks. And there are a lot more to mention. After going through so much in this pandemic, this graph coloring would bring an advanced utility to people, which generates a scheduling outcome while utilizing graph coloring to help in solving current issues in the Philippines. Now let us know more about graph coloring and the components of this video. We will be defining the important names and terminologies in graph coloring, and in line with it are the types of graph coloring and some real-life examples. I will be making a short backtrack on what is graph theory. Graph theory is used to find the shortest path in road or in a network. Also, it can be applied in engineering and science. It is a simple way of labeling graph components such as vertices, edges, and regions under some constraints. Now that we know about what's in it for you in this graph coloring, let us now look forward to terminologies that we will be encountering along the discussion. Let us start with the term chromatic number. It is the smallest number of colors needed to color a graph G, often denoted as x of G, chromatic polynomial. It counts the number of ways a graph can be colored using no more than a given number of colors. K coloring, coloring with the most colors. Frequency assignment, a set of connection to whom must be assigned a frequency of bands or channels and has some optimization criteria into interference between channels. Four-color map theorem. There are no more than 4 colors are required to color the regions of the map so that no two adjacent regions have the same color. On this episode, we will be focusing on two types of graph coloring, namely the vertex coloring and the edge coloring. What is vertex coloring? Vertex coloring is an assignment of colors to such vertices of graph G such that no two adjacent vertices have the same color. Simply put, no two vertices of an edge should be the same color. In vertex coloring, you can use the 4-color theorem. If you want to use more than 4 colors, it is denoted as K coloring or coloring with the most number of colors. In simple definition, chromatic coloring is the number of colors in the colored graph. And in these examples, x of G is equals to 3. 4-color theorem is usually used in this vertex coloring. Just like in map coloring, there are contiguous regions which are put into plane, and no more than 4 colors are required to color the regions of the map so that no two adjacent regions have the same color. Adjacent means two regions share common boundary curve segment, not merely a corner where 3 or more regions meet. Let's now discuss the two kinds of vertex coloring. First is map coloring is on your left side. It shows a 4-color map theorem wherein separation of a plane to make regions contiguous would create the map itself. Next is frequency assignment on your right is considered as one of the most prominent applications of vertex coloring problems, which models range from the most naive forbidding monochromatic edges. Now we know about what is vertex coloring. Let us proceed to edge coloring. Edge coloring is an assignment of colors to edges of the graph so that no two adjacent edges have the same color with an optimal number of colors. Two edges are said to be adjacent if they are connected to the same vertex. Just like in vertex coloring, four-color theorem is also applicable in edge coloring. However, edge chromatic number is the number of colors in the edges of this planar or graph. Minimum edge coloring is denoted as G, or in this case, G is equals to 4. What do I get from using this? Let us now apply graph coloring in real-life problems. Let us now make things easy. In this video, I will be giving two examples of vertex coloring. The real-life applications will relate to the current situations in this pandemic. We will be proposing possible solutions using graph coloring. Under the example of map coloring, the issue under the latest coronavirus news was that Region 4A Regional Director Eduardo Hanario a total of 7,190 coronavac vaccines were allocated for medical frontliners of 13 hospitals located in various provinces in the region, which is in Calabarzon Region 4A. In this map coloring, we will be plotting the target locations of the registered hospitals that will be receiving the vaccines. The plotted dots shall be distinguished and combined into one as a province mark. The borders will serve as their gates from the other provinces near them. This is to target the province who has the greatest access to different provinces so that we can focus on disseminating more vaccines to them, since they are more prone to getting more of the virus. Now, you can see green dots are located and plotted in the Calabarzon map. Let us now make it in dotted locations. We have the 5 provinces in Calabarzon. And as we can see, in Cavite, Batangas and Laguna are accessible to its borders. The one with the highest access to every border is in Laguna. Now that the nearest boundaries are connected, let us see how many would be accessible to each provinces. In Laguna, let's color it blue, who has the most number of access to different province. Next is Batangas, and let's color it red since it is already connected to a blue one, which already has 3 access to different provinces. Since Rizal is not connected to Batangas, we can color it also red. Since Quezon and Cavite are the only left with no color, we can color them both yellow since they have no connecting paths. Now that they are all plotted and colored, this is how the map should look like after plotting all the colors. Now it is more distinguishable which provinces should be first in distribution of the vaccines. And now that DepEd are targeting to practice back to school with some of the limitations and prohibitions to keep the safety of the students, let us have an example of grade 12 senior high school back to school problem. If there are 10 sections that consist of 3 ABM courses, 3 STEM courses, 2 UMs, 1 Arts and Design, and 1 Sports track, with only 4 floors, and there should be no same track per floor, we could use 5 colors to present courses. This is also to practice what is the most significant and important. The coloring of the classrooms should be different from the vertices connected to it so that it is easier to distinguish which classroom should be available for the courses. And after coloring it all, since there are 3 color reds, it can be indicated as ABM, and 3 color orange can be STEM, 2 for UMS, which is yellow, and 1 for ADT and SPT, which is green and purple. Now we're done. It is very easy to use graph coloring. If you want more, please watch the next video. See you there!